All right, so today we're doing our last thing of how to solve quadratics, and we're going to use the quadratic formula. Okay. Uh, Remember, this is our equation. We always will have ax squared plus bx plus c equals 0. Now, this whole thing right here is our quadratic formula. Okay, so it's kind of confusing at first, but literally it's a plug and chug. And I'll step through this step by step for y'all to do. Okay. Now, this part up underneath the radical sign, that's called discriminant. Okay. And this will help us find our roots. Let us know if we're going to have real roots or something else, because now we get to talk about imaginary numbers. And this question may be important because it may be something related to the practice test and or test, hint, hint, wink, wink. It's mainly used when you can't factor something. Okay. So that's what we're going to kind of focus on for that. All right. But believe it or not, you can solve all quadratic equations with this. You don't have to choose, even the ones you can factor, you can use this. I have some students that they will always use this. They will never use factoring and definitely will not use completing the square. All right. Now, so big thing about this, if the discriminant is 0, okay, if the discriminant value is negative, okay, if we were to graph it, it would never touch the x-axis right here, okay? This is where we're going to have our imaginary numbers, okay, and we're going to look at those later today. Now, if it's 0, it's going to touch this one time, and if our discriminant is positive, it touches twice, okay? So, again, now, when it's saying number of roots, this is the real numbers, okay? And we have to say that because apparently long ago somebody says, wait a minute, what if you were to take a square root of a negative number? It wouldn't be a real number, it would be imaginary. Now, there's a whole part of mathematics just dealt with imaginary numbers. Nope. I really wish I was. But I spent many a Saturdays with a professor from Alabama graphing stuff on the XY plane, changing those things to polar coordinates, and then changing them to imaginary coordinates. It's awesome. All right. Now, for our directions, this, find the discriminant, state the number of roots, all that kind of stuff. We're not going to solve these first 3, okay? You can go back and solve these later, but main thing I'm going to work with is discriminants. Now, I would always pull out my values. Okay, that way I know what to plug in. All right, so -4. Now I'm setting it up like this again because this is how you'll type it in the calculator. So the -3, make sure the negative is on the inside of the parentheses, 1 and -28. So when you actually do this, you can actually type it in the calculator just as it's written. Okay. And this value gives us 121. So that means it's positive. Okay. When it is positive, it has 2 roots. Okay. We used to have, yes. Yeah, basically what we're going to be doing today is we're going to be taking the values from the given equation, the first one, as you said, and stick them into a formula, and then we never look back at that graph again, never look back at the first equation again. Yep, same formula. Well, is it your test open notes? So, yes. All right. Now, for this one, A is 1, B is 5, and C equals -3. So, when we plug this in, it goes like this: 5, 1, -3. All right. Minus 4 times 1 times -3. All right. So this value we get is 37. Now that's our value. That's not how many roots we have. Okay. So we actually just have 2 roots. Now, again, we used to do a lot with the discriminant. There was a problem question on the test like that, but we're not doing that anymore. I'm just getting y'all used to taking in the numbers and plugging it in. Okay. And then lastly, A is 9, B is -6, C is 1. By the way, if you like my singing, catch my track on SoundCloud. All right. And then this is 9, and then this is 6. Okay, so I was running out of room there. I really should have wrote it somewhere else. Yeah, it's -6. But this gives us 0. So we have one real root. That means it's going to look like the graph where it just touches the x-axis once. Okay, well, -6 squared, that's 6 times 6, that's 36. Okay, minus 4 times 9 is 36. So 36 minus 36 is 0. Yeah. All right, so we're going to have one real root. Now, this is basically kind of warm up, getting you used to using this formula. Okay. The reason why I would always start with the discriminant. Okay. And when you see me work these out, you'll kind of figure out why I always start with the discriminant. Okay. So, oh, wow, look at this. It's like somebody made it all nice and neat for us so we can plug in. All right. So, first thing, look at our equation. We cannot find our A, B, and C right now because 0 is not on one side. So if we add 1 to both sides, we end up with 3x squared plus 5x plus 1 equals 7. Okay? So we have A is 3, B is 5, C is 1. All right, now we're going to plug this in. 5, well, that's gross. 5 goes here, 3 goes here, 1 goes here, and 3 goes here. All right, so, well, negative times 5 is going to be just -5. Okay, 2 times 3 is going to be 6. And we're going to have plus or minus. And we learned about that yesterday because we got to take the positive and negative root. All right, so the discriminant okay, is 13. Now, there is no square root of 13 that's not a decimal. So guess what? We're done. Yeah. Yeah. We can go no further with this problem. This is why a lot of people like this more than completing the square. Some of y'all are like, it has to be more to it than that. Not this problem. This is done. Now, some of the other ones, we're going to have to do something else, but that's it. Kind of neat, ain't it? Now, if y'all are good during the lesson, after I get done recording, I will show y'all probably the most Caucasian thing I've ever found on the internet. Okay. I know, it's awesome. No, it's not. No, it's not. All right, so same thing. We can't really do this till we subtract 9. So now we're going to have 6x squared plus 3x minus 9 equals 0. All right, so that means A is 6, B is 3, C is negative 9. So I literally, this is just a plug and chug. You just take these numbers and you plug them into this formula and you chug out the math. 6, negative 9, and then we got the 6 right here. All right, the formula that's at the top of your page is right there. Normally, I would kind of rewrite it, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, but I didn't really copy and paste that down because it was already right there on your paper. Yeah. So now, well, negative times 3 is just negative 3, and 2 times 6 is going to be 12. We got the plus or minus, and now we do the discriminant. Okay. 4 times, whoops, not 48. 6 times negative 9. All right. Now we get 225. Okay. We can take the square root of 225, which is 15. All right. Now, believe it or not, we're almost done. Okay. Remember yesterday when we had the, we had to do the positive version, the plus version, and the minus version? Well, now we're going to do the same thing. We're going to have 3 plus 15 over 2. And then we're going to have, or negative 3, and then we're going to have negative 3 minus 15 over 2. All right. This is 12 over 2, which is 6. Negative 18 over 2, which is 9. All right. So our final answer, x equals 6 and 9. I know. I don't like quadratic formula problems that actually has a discriminant with a perfect square, because that means we got to do more work. I like it with a non-perfect square. Yes, sir. Oh, yeah, it is negative 9. Sometimes I don't even see the negatives. I'm glad y'all can. You and your young eyes. But I don't know how good y'all's eyes are going to be at staring at screens less than 2 feet away from your face all the time. Yep. All right, moving on. Now, to the back. Now we get to talk about the imaginary numbers. Okay. So the best I can kind of just figure out is because opium was used like Tylenol back in the times when they were creating all this stuff, that some mathematician had a headache took some opium and decided, since he was high, they were going to make an imaginary number. Okay. I don't know if that really happened that way, but if you kind of think of it that way, it kind of makes sense why this makes no normal sense. Okay. So, this is, if we had the square root of 25, that's basically the square root of 25 times the square root of negative 1. Okay. The square root of 25 is 5. And the square root of negative 1 is I. Okay. And that works for a couple of different things. Like, let's do this one. Square root of negative 16. Okay. Well, the square root of negative 16 can be written as 16 times negative 1. Well, what's the square root of 16? 4. Thank you. What's the square root of negative 1? Nope. I'm underlining something for a reason. I. Yes. Okay. I didn't hear it. That's it. Now, I'm going to show you one that's not a perfect square, but the calculator will reduce it for you and show you how to do it. Okay. Now, let's say if we have the square root of negative 12. Okay. What I would do, if you ask Mr. Jeffries, WWJD, what would Jeffries do? Okay. Jeffries would sit here and type in the square root of just regular 12 in the calculator. That's all I would do. I'd type the square root of 12 in the calculator. Don't put negative 12 because it will say domain error. Okay. And I'm going to get 2 root 3. Okay. And then all I have to do is put an I right there. The reason why this works out is because this is the same thing as saying 4 times 3 times negative 1. Well, the square root of 4 is 2. The square root of negative 1 is I. Okay. This normally used to be a Algebra 2 standard, but now they've added it into Algebra 1. And this is actually as far as we have to go with it. So we're using this now to find those imaginary roots using the quadratic formula. Okay. My hand's itching. That must mean I'm going to get money. All right. All right. So now look, aha. This makes more better sense than a while ago. Because not only does this have spots for A, B, and C, it has the formula and tells you where to put them in. So A is 1, B is 5, C is negative 3. Okay. So now one of these, I think we don't get an imaginary number, and the other ones we do. I can't remember how I set it up. All right. So when I plugged it in, that gives me negative 5 plus or minus, and then this is 2. All right. So 5 squared minus 4 times 1 times negative 3. All right. I get 37. There's no square root of 37, so I'm done. Okay. Now, the thing is, like last school year, if we would have had a negative underneath the square root, you would just say no solution. Now, we're going to know that negative numbers exist, so we'll have to pull them out. This one just didn't have one. Okay. So let's look at this one. All right. First thing I need to do is let's move the 4x. So now we have 3x squared plus 4x plus 4 equals 0. All right. So A is 3, B is 4, and C is 4. So we plug it in. 4, 4, 4, 4, 3. Okay. It's 3 times 4. Oh, nope. I accidentally hit 1 instead of 4. All right. I get negative 32. Okay. So we know this is going to have an I in it. Okay. So in my calculator, I'm just going to take the square root of 32 and see if it reduces. Just so happens it does. It reduces to this right here. So I'm going to have negative 4 plus or minus 8. Now on the calculator, it says 4 root 2. Okay. But what should be between the 4 and the square root sign right there? Because there was a negative up underneath it. I'll give you a hint. Look at an I. Lauren, you're looking very confused. Where? Oh, it's supposed to be a 3, so that's even better. Oh, so you're confused about that, not the square root thing. Listen, when y'all sit there and y'all have the who farted faces, I know that y'all don't understand. So please speak up. Okay, is that more better? Okay, good deal. Now, look, I did it again. I said 6 here, and I said 4. 6. All right. So, and the reason why this works out is because square root of negative 32, that is 16 times 2 times negative 1. Square root of 16 is 4, and the square root of negative 1 is I. Now, let's look at this. I want to highlight something that you kind of need to look at. What do we notice about these numbers right here, other than them being red and highlighted in teal? They're even numbers. So what can you factor out of an even number? What divides all even numbers? 2. So we can actually reduce this fraction down. We factor out a 2 from everything. So negative 4 divided by 2 is negative 2. Two times 3. So my final answer root 2. Wow, that 2 looks janky. Over 3. All right. So I'm gonna ask a question because I'm sensing something. My spider senses are tingling. That the quadratic formula, the plug it in thing, y'all got that. Y'all can understand how to plug stuff in. Y'all still aren't really getting the square root of a negative number, right? It kind of goes against everything you've been told thus far. Okay, let's do one more, and then we'll we'll do some more square roots of negative numbers, okay? All right. So let's look at this one. All right. Let's move this 2x right here. All right. Now this gives us x squared minus x plus 2 equals 0. So a is 1, b is -1, c is 2. All right, so y'all double check me when I'm plugging stuff in, because apparently I'm going rogue. -1, -1, 1, 2, 1. All right. So out front, I've got a negative times a negative. Well, that's just positive 1. Okay. And then I have 2 right here. Now I have the square root of all this stuff. And this is where I'm going to lose people. All right. This gives me -7. Okay. Now, the square root of -7, okay, can be broken down like this. 7 times -1. Okay. What is the square root of -1? I. So that's the only thing we can take out. Well, we can't take the square root of 7. So this is just 1 plus or minus I root 7, 2. All right. So now with the I thing, is it just because it's new with the -1, or that kind of cheating and typing numbers in the calculator and getting these weird like 3 root 2 stuff? Or it is? Okay. So this is what I would suggest. Okay. Let's see this. All right. So let's say if we had the square root of -48, and you could write this. Did we have another problem to do? Or were we done? I think we were done. Hopefully you have room on your paper. If not, you could write this back up at the top where it talks about the negative number. Okay. Now, all right. We know something's gonna be this is 48 times -1. Okay. What is a perfect square that will divide 48? What's the number that you see right here besides 4 that will divide 16? Okay. So we can rewrite this as a square root of 16 times 3 times -1. Okay. Now, this is the thing. Some of y'all are getting lost on the fact of he's simplifying this radical thing and I don't understand. What have I said to use? No, when you're simplifying radicals, what have I said to use? Calculator. Okay. Use the calculator. All right, because it will do it for you. But what is the square root of 16? What's the square root of -1? And then 3 stays in the house. Okay. So this is what I'm going to do. I'm going to quit recording, and we're possibly going to do some calculator work real quick.